Hello, I'm Charlotte, and I was wondering if you're as interested in crime scene investigations like I am. Well, historically, crime scene evidence has been communicated to us through proteins for many years, but there have been some limitations. Here are two innovations that have been brought to us through the use of mass spectrometry and proteomics. That's going to help you solve the case sooner. Let me give you a minute or two on why protein in crime scenes is so exciting. Well, for many years, protein has been used long before the DNA revolution, and in some cases, it's even used independently today. Protein has aspects to it that will help us identify what the sample is and help us lead us to the suspect. This is how we determine if it's blood or bodily fluid, and it can determine the genotype. The material from proteins are super important because in biologically or environmentally degraded areas, the DNA will be long gone, but the protein will remain. I will now explain to you the 3 steps of proteomics and mass spectrometry, starting with number 1, preparing the sample. As we take a sample from the crime scene, we don't know what it is. It could be blood or body fluids or tissue, but we do know that it is too big to fit in a mass spec. So we must add a protease, usually trypsin, to break the sample down into smaller bits called peptides. We are going to take those peptides and talk about step number 2, instrumentation. Here, we send the peptides into the mass spec where they are heated and deflected by a magnet. That deflection causes the ions to separate and become detected. That detection shows how the ions in the sample are inversely proportionate to the mass over charge ratio. This will then be translated into a graph. The third step in the use of mass spectrometry and proteomics is the data analysis, which we will graph the information we receive from the detection process. Here I show you an example of the graph, which is atomic mass compared to abundance for blood. So blood has various components, including albumin, which is high in abundance, and cytokinase, which is low in abundance. This new technology can differentiate those different aspects in the same sample, and after those parts are differentiated, they are compared to peptide libraries, which scientists and investigators use to interpret the sample. And these 2 new technologies are key advancements in the use of mass spec and proteomics. This will help crime scene investigators. I hope you can find this as fascinating as I do. This is why protein is so important in crime scene investigations. Thank you for watching.